Hello, once again, BC Calculus students. Let's go ahead and let's take a look at how to score our first three questions from our 2019 free response here. So this is the test that I actually graded last year, so I should be able to give you some pretty good insight into how a number of these things were actually graded. So we'll hope I can give you some good insight anyway into it. So let's go ahead, let's take a look here. So question number one, what we see here is we've got our fish entering the lake and leaving the lake. So once again, this is our rate in, rate out problem, the basic structure here. And it looks like we've got rate we have two different equations, but both of them give rate, so they're similar in that regard. All right, let's look at how we're going to score this question. So first for part number one, so this is just rate entering. They do make it nice. They make it E for enter and L for leave. So over the 5 hours there, it's going to be the integral from 0 to 5 of E sub t dt, and you get the answer of 153.458. So you get 1 point if you get the integral. You have to have this integral expression here. If all we see is an answer or something like that, we don't see how you got that answer, you're not going to get your integral point. Okay? You need to have that integral there and be visible in order to get that point. And then if you actually get the correct answer, then you end up with 153. It does say to the nearest whole number, so you should say 153, but we didn't count off if you went out and you did and you put in the decimal answers as well. So didn't subtract if that was the case. Then and this is one I'm getting you the information both from the answer guide and from friends who I talked to. This is not actually one of the questions that I personally graded last year. Okay, then B is also worth 2 points. So 1 point if you have the correct integral. Now the integral includes the limits 0 to 5, and it includes that you use the leaving function, the L of t dt, and the answer point ties together that you punched in your calculator correctly, and you need to divide by 5 or multiply by 1/5 and get the correct answer there. So that would be your answer there for B. Now for C, you start off with a soft point. It is a soft point for recognizing you're looking for where the difference between the two rates is 0, or that can be expressed as looking for where entering and leaving are equal to each other. Either way works there. And then if you actually go and, so if you set that up, you get your, you get 1 point. If you do calculate the actual time where that happens, which is going to be at 6.204, then you get 1 point. And if you have the correct justification, okay, so the correct justification here is essentially that the difference in this and the difference in the rates there is positive, and then afterwards it's negative. Therefore, that must be the maximum rate there at that time. So that would be where the greatest number of fish in the lake would be. Okay, the alternative way to do it would be to do it this way. This is using the candidates test to simply calculate, to know that it must occur, the maximum value must occur either an endpoint or at a critical point. Find the critical point, which is the same thing here. Check the amounts at each point, and then you find that C would be the correct location, and that would be the correct amount. So that would be the other way, is using the candidates test, worth 3 points. Okay, part D. Part D, if you consider that you have to look at E prime of 5 and L prime of 5, you get a point. That's a very soft point. But if you just know that you have to look at both of those and you can see evidence that you did, then you get 1 point. And then if you actually go and calculate the difference, find out that it's negative, and then express that means the rate of change is decreasing, okay, then you get the And so notice that's actually the rate of change in the number of fish that is decreasing. So it's a change in the rate of the rate. So it is important that you do have that distinction. It's not that the number of fish is decreasing. It's the rate of change in the number of fish is decreasing. Okay? So it's very important, just like you can't say that the rate is negative. It's that the rate of change of the rate of change is negative, is what you've got there. So you have to be careful with that explanation. Okay, score that out of 9. And then let's move on to question number 2. Question number 2 is one that I actually scored. So we'll see how well I remember exactly what we accepted. So for part A, you get 1 point for your integral. That includes limits, and it includes the r of theta function that is squared. Okay, to get that integral point, you must have the correct limits, and you must have that correct function squared. This 1/2 could be inside or outside. It's not required though for the integral point. So if you forgot the 1/2, you can still get your integral point. And then when you go ahead and evaluate, and if you get the answer, then you get the second point. Part B, once again, you get 1 point for the integral. That includes the limits, and knowing that you must integrate r of theta d theta. So if you do that, you get 1 point. And then if you understand that you have to multiply it by 1 over pi, or divide by, 1 over square root of pi, or divide by the square root of pi, and you do it correctly and get the correct answer, then you do get the second point. Part C. Part C, this is the one that really students did not do well on. C. A and B, a lot of students did quite well on. C and D, not so much. For C, you get 1 point if you equate the polar areas. So in other words, if you understand that it's going to be these two areas, if we see an expression where you have two areas that are equal, area functions, polar area functions, you get 1 point. You get a second point if you have an inverse trig where m is the limit of the integration. So in other words, if you understand that this m that they're talking about goes into an inverse trig function. So if we see that expression there, anywhere where we see an inverse tangent there of m, or they could refer to that as an inverse sine over inverse cosine. That would also work. But some sort of inverse trig of m, you get that second point. Finally, putting it all together for the correct equation. Now, they've listed it out this way. That's fine. A lot of times students recognize that the 1/2's canceled and they just drop those 1/2's there. That's fine if you did that. If you drop the 1/2's. The key thing here, though, is that this here has to be half of whatever the expression here is when you're looking at that. So that gets you your all 3 points. That one students really struggled on. D was a little bit more hit and miss, but it was still pretty tough for students. Number 1, limits of integration. So your limits of integration here had to go from 0 to pi over 2. So if you knew that you had to go from 0 to pi over 2, pretty simple, straightforward, you got a point. That point was easy. A number of students got that point. The second one was a lot harder to do. And that's where you actually had to know that you needed to take the limit as that the limit as k went to infinity was equal to this integral here. And so you actually had to do that correctly, set up correctly, and have the answer there in order to get, if you just had the answer with no integral, you wouldn't get that point. Took the integral and the answer to get that point. Okay, go ahead, score that one out of 9, and let's move on to number 3. Number 3. Okay, so what we see here with number 3, and I'm actually remembering here, I do believe this was one that, I'm trying to remember if this was one that I did or not. I don't think this was one that no, this wasn't one that I did. So I was going to say it doesn't look very familiar, so this wasn't one that I had done. All right. So what we see here is we see that we've got the 1 point for getting this correct expression, that going from -6 to 5 of f of x dx is going from -6 to -2, and then from -2 to 5. So 1 point for making that connection there, that this is equal to this. 1 point for going ahead and finding out the value of -2 to 5 of f of x dx. So getting that value from -2 to 5 of f of x dx, we can see is this expression right here. So if you got that, that 2 plus 9 minus 9 pi over 4, that got you your that got you an extra point. And then finally, if you did the answer all correctly there, you could have left it like this, or you could have written it as 9 pi over 4 minus 4. That got you your third point. Then for part B, so your fundamental theorem of calculus gets you 1 point. And essentially that is this expression here of that it's knowing that you take the integral of this derivative becomes just f of 5 minus f of 3. So if you get from this step here to this step here, you get 1 point. Okay, so you have to have this step, and then you have to correctly get to this step. That gets you 1 point. And then actually evaluating everything correctly and getting it out, that gets you your second point. There is another way to have done that one. The other way you could see would be, rather than separating it up, just simply anti-differentiating. That would be going from right here to right here. That would be going from there to there, not breaking up into separate integrals, integrating each part there, and then doing the correct evaluation. So if you get to here, that would get you your first point, and then your second point would be in your correct evaluation. All right, part C. Part C is worth 3 points. So you get 1 point for equating g prime with f of x. If you establish that relationship somewhere, and we can see you've established it, you get a point. But you must establish that relationship. You must say somehow. It could be in your explanation, it could be somewhere, but we need to see that. If you identify -1 as a candidate, so as you look for your critical points and you come up with -1 as a candidate, you get another point. And then if you go ahead, and this is an example of the candidates test, checking endpoints, finding values at endpoints, checking critical points, finding values at critical points. You're looking for the absolute max. And so what you can see pretty clearly here when you take a look at this is that your absolute maximum is going to be this value here, which is clearly bigger than 1/2. So it's going to be that value there. Your justification is your chart, is that you checked all the candidates. Finally, D, got a little L'Hopital's rule in action here. I believe we have L'Hopital's rule. No, we don't have L'Hopital's rule in action. Sorry. We're going to go ahead here and take this limit, solve for this limit. So substituting in here, this is just all one thing. That answer gets you. Now you can simplify this so long as it simplifies correctly, but working this out here will get you your point. You must work it out completely. So this is one where you can just simply substitute in 1 into the values and evaluate, and you're fine. So the key is knowing how to set this up here. Knowing how to set that up. All right. So with that, go ahead and score that out of 9. Score the whole thing out of 27. And then go ahead and take a photo and turn that in. I'm going to take a look there at that last 3D there and see just what they're asking. Yeah, so it's just the key is knowing how to interpret the value of each one of these expressions by looking at the graph and coming up with the correct answers for those. Yep, that was it. Okay, that looks like that's it. Hope things are going well, and we'll have a Zoom session tomorrow if you have questions.